everyone, welcome to questions on synthetic roots. First question we have here is we have compound B and compound F, and we're asked what the empirical formula of compound F is. So to start off, all you need to do is to add up how many carbons you have, which would be 4, how many hydrogens, which you have 10, and then you've got 2 oxygens, and then simply you can take those values and you can divide them all down by 2, because the empirical formula is the simplest whole number ratio. So that should give us C2H5O. Next, we have a two-stage synthesis. We're going from compound B to E, in which we need the reagents for stage 1, and then the structure for E, and then the reagents to go from compound E to F. Now, again, you got to look at where you're starting and look at where you're finishing up at compound F. So I know that I'm not going to have that double bond to the carbon. That's not going to be there. That's probably going to be removed in this first stage. And I need to think, right, okay, well, once I've got rid of that double bond in the alkene, and I've got a carbon-carbon single bond, and I need to find a way to then form those get those OH groups on there. So I know I must add something in that then gets replaced by those OHs. So it seems to me what the best thing to do would be to have a halogen there. So reacting it with one of the halogens and forming a dihalogen product. So you could have it with chlorine, bromine, or iodine. I happen to go with bromine this time, but if you have, instead of the bromines there, if you've got your chlorines or your iodines, that'd be absolutely fine as well. Like I say there, you have that addition in there, so we lose that carbon-carbon double bond. And then going from there, we're simply going to be swapping out our bromines, or whatever halogen we have, for those OH groups. So in that case, we need something that has an OH group on there, being sodium or potassium, something along those lines there. Again, another two-step synthesis. We need to draw the structure that's the result of step 1. Well, if I'm looking there, I've got HCN, got hydrogen cyanide. I know that that CN is going to be reacting as a nucleophile, so that would then go and attack the carbon double bond to the oxygen. The bond in the oxygen, one of the double bonds in the oxygen will then go to the oxygen, and then the hydrogen will come in. So I know the gist of what's going on there. Now, if you want to jot down what's going on in terms of the mechanism to the side, absolutely fine. I'm sort of running through what's going to be happening so I can see what I'm going to have, which should be something that looks like that there. So the addition of that CN and that H also going on there as well. Now I need a reagent that could be used for step 2. So very simply for this, I just need some form of an acid. Some sort of aqueous acid, sulfuric, yeah, I was absolutely fine with that. Okay, we have another two-step synthesis, but this time I want you to write the mechanism, relevant dipoles, curly arrows, intermediates formed, and all that sort of stuff. Worth 4 marks. So, first bit we need is from that OH group that we have sort of floating around there within the minus charge, we need to have a curly arrow pointing to the carbon double bond to the oxygen. Carbon is delta positive, oxygen is delta minus, and then one of the bonds going from between the C and the O going to that oxygen there. Make sure we've got those arrows there, and make sure we've got those dipoles there. Next stage, we see, because now the oxygen would have that negative charge on there because it has an extra electron that it wouldn't normally have, that comes back in to form that double bond. So we know that's where we're aiming for. We look at our final product, we know we're aiming to have that double bond still there. And then that's going to sort of help to kick out the OCH3. So again, make sure we got our curly arrows in, and that will then form our second step there. So we have our curly arrows, have our intermediates, and then that would actually form our products as well. Okay, so hopefully that's okay. Lots of two-step synthesis questions. You need to be comfortable with those sort of questions, so make sure you get some practice in with those. And finally, last question, we need to show what's going on methyl lactate and ethanol chloride. So for this reaction here, even though it's sort of written this way around, we want the OH group. This OH group here would attack as a nucleophile to this carbon here. And then what happens very loosely, again we have a curly, oh, we saw before, curly arrow would go to that oxygen there, forming that minus charge on it. This oxygen would actually have a positive charge when it then reacts and actually forms a bond with it. And then what happened is this oxygen here would have a minus charge. This would come back in to reform the double bond, and then this would then get kicked out. So that's a very, very loosely, very badly drawn mechanism there. But you're not asked to draw the mechanism, just hoping to give you a bit of an idea of what's going on, and that would be what the product that we formed there. Okay, so that will do us for today on reactions of synthetic roots. See you next time.